of today's webinar, which is a joint ETIS Intel Lenovo webinar. And the topic, I think, is on everybody's mind for at least over a year, when ChatGPT took, I think, by a landslide, the attention. It was also a big topic at the Mobile World Congress, AI. I've met many of you who are in the webinar today, and as you've all seen, it's on all companies' top of mind. So this webinar is a very good introduction also to the ETIS gathering, which we will have on 4th and 5th of June in Prague, where we really want to go deeper into AI opportunities in the telecom industry. We do believe that it can transform and shape the future telecom industry, but it's also good to go a bit beyond the hype. I think in the Mobile World Congress, it looked like there were a lot of low-hanging fruits already. I think it's fair to say that we still have to discuss more and to see what the roadmap is to use AI in the different internal activities of a telecom operator, as well as also to see how AI can be used to offer new services to our customers. So we have a very interesting agenda, I think. We have speakers from Lenovo and Intel. We'll discuss the drivers of the telco AI machine learning and discuss use cases. We will give some use cases in operations, in the radio access networks, in customer experience. So here you see the speakers of today. It's a mix of Lenovo and Intel. I would like to introduce ETIS also briefly for the people who are in the webinar who do not know about us. ETIS is in fact a collaboration platform in the European telecom industry. We have 30 telcos operators in Europe as members, and we also have 18 service providers, suppliers, vendors who are supporting us. And it's really our aim to discuss strategic topics, best practices, challenges, things which go well, things which did not go that well, or even failures, so that you can learn from one another. We have 18 working groups and task forces. I will not go into any detail. We basically cover all telecom activities, except we don't do regulation, and we don't do standardization. We have sister associations already taking care of that, so we don't want to duplicate their work. Feel free to go on our website, etis.org, to have an in-depth description of our activities and of the working groups. We have some webinars coming up before the gathering, early June. You see them mentioned here. You will get the slides, so no need to read them out here. And we will also, as already mentioned, come together with most of our working groups in Prague on 4th and 5th of June. And so it's a very good timing to register. We have some very advantageous offers now to book a hotel room. The event is also free of charge to attend if you're a member. If you're not a member yet, you can also contact us. We have some free passes still left. Before giving the floor to Dominique, I would like to highlight some guidelines for the webinar. Please mute your microphone. We have a lot of participants, so it's good to avoid background noise. We want to get your feedback and your questions, and for doing so, please use the Q&A function, which you find on top of your screen. We'll also ask to participate in a poll during the webinar. So we'll do some explanation when we arrive at the poll. At the end, we would like to have a small survey filled out by you. So please participate in it. It's as well on the content of the webinar to get your views on a number of topics related to AI. Also, some feedback related to the webinar is always welcome. And we will also share the slides, so no need to make pictures or copies. Sit back and relax, I would say, and listen as much as possible. And we will also share a recording link of the webinar. So that's it from my side. I would like now to give the floor to Dominique from Lenovo.
Yes, and good morning, everyone. Thanks, Wim, and thanks, ETIS, for giving us the opportunity to present. I am leading the Telco business unit for Lenovo, and I'm joined here with our friends from Intel, and we have a pretty good agenda, I think, and a lot of content to share with you. As Wim said, this is meant to really be interactive, so we use Teams for that matter. So use the Q&A, make sure it's interactive. We have polls, as we can see, popping up to make it a bit more lively. And as Wim said, we really would like you to fill out the survey. So don't leave the webinar before filling the survey. We will share the results of the survey, obviously, when we do the Prague gathering in a face-to-face fashion. And probably a lot of more information coming from this webinar. So please, as Wim said, sit back and relax, but also be pretty interactive. Yes, EI and Telco. So with our friends from Intel, what we really wanted to do today is to bring it really to bear in the Telco fashion. You will see that we really will emphasize use case. So use case that we have seen from the Lenovo side on a global basis, or from the Intel side, things that we have done ourselves and things that we have seen with other telecom operators in the world. So we really want to make it as pragmatic. So pretty much in the spirit of ETIS, we want to be in a sharing mode, but also being very realistic with some of the technologies that we will be sharing. So yes, we will be covering the heart of the possible, but on the other hand, also we will put some perspective and things that are very pragmatic. So why EI and Telco, you would say? EI and Telco is an interesting combination. Telcos have been using data and have been leveraging data for the last 60 plus years, if not more. Telcos have been sitting on huge data lakes and certainly have been using a lot of analytics tools and big data tools to really mine those data environment. And yes, some of these applications and use cases that you will hear from us, and they're probably already deployed in your own organization, are linked to network optimization, making sure everything is as cost efficient, as reactive, real time. We still live in a world that is 5.9 SLA type of environment. So network optimization is certainly a big element of that. But central to all organizations is obviously the customer and the customer demands, making sure that the user, the subscriber, has a very seamless experience, that we protect the loyalty and avoid churn. So the customer focus and the benefits from deployments of AI, machine learning, or deep learning, or large language models are really with that in mind. Obviously, we live in the zettabyte era. There's tons of data being created. In 2023, there was on average 330 terabytes of data created every day on the globe. In 2025, there will be 180 zettabytes of data being created. So we're looking at an explosion of data. And obviously, telcos are the center of that. Obviously, telco are the master of transporting those data, of storing, of computing, and also securing all of that data and all of that traffic. But we definitely want to leave you also with a lot of information and a lot of ideas potentially where it's not just a ChatGPT world. It's really a lot of applications and use case. And this is not just a place for telco competition, hyperscalers, OTT, and others. AI can provide use case and applications that are really beneficial to the telcos in different flavor. And obviously, a lot of telcos have been embracing AI. Some of them really taking AI as the lead strategy. Telenor and South Korea Telecom has been very vocal to turning the company into an AI company. So when we look at the use case, and here we show you just a menu of around 40 use cases. But the more important piece here, we believe it's really the different categories that we want to highlight. Obviously, network operations, making sure every piece of the network, the mobile piece, the 5G deployments, the fiber, the fixed environment, the copper, data, voice, IoT type of traffic really needs to be optimized and be as resilient and as effective as possible. But telcos are also very large enterprises, so business operations, in our mind, goes beyond OSS and BSS, and really also look at how AI and machine learning and large language model can really improve telcos as an enterprise. And then on the left-hand side, it's all about customer experience. It's all about reducing churn. It's all about loyalty. It's all about making sure that the subscriber has really the best possible experience. And enterprises like telcos needs also to look at new revenue streams, new type of business, ARPU obviously being a central element here. So how can AI improve not only the profitability of some of the business being in place right now, and how can existing services be optimized by AI, but also can we look at new revenues for new streams of revenue, being in very specific net new revenue. Data sovereignty, AI sovereignty are big concerns for governments and countries these days, but also some very specific vertical solutions. So jointly with Intel, we have a couple of use cases that definitely match all these categories. A couple of things to flesh it out a little bit more concrete. We have Telco Edge AI for edge computing solutions using computer vision, serving public safety or retail as new revenue streams, for instance. We also have a European operator that has started a metaverse service or another services based on digital twins. So you could see that we have a really large portfolio of potential use cases in front of us. And we just cover here a couple of those use cases. So in the rest of the webinar, we will certainly cover a bit of that. Yeah, to make it a bit more interactive, let's have a quick poll question. Again, this is polls that we will have, so you should have a pop-up coming up on your screen right now. And again, we will have a survey at the end. So take just maybe 2 seconds to answer and just give us a bit of a feedback of what you think are the primary goal for your company in terms of those use case categories. All right, Mike, let's go straight into it. So Mike, why don't you take it off from here?
Thank you so much, Dominic. Yes, and I'm just watching the results, and as expected, we see quite some votes for customer experience use cases as well as for network operations, lesser on business operations and the revenue streams. That actually nicely aligns with our view of the industry where we are currently in the telco industry applying AI/ML and the primary goals for it. So with that, we have prepared 3 different use case scenarios in 3 different areas. And I'm going to start with the operations side of the operators. And where we always work with network analytics. It's always been an important part of telco operations to assure network uptime and service quality. But traditionally, that was managed in silos, and the different domains have been operated and surveyed separately. For example, the core, the access, and the transport networks. But now with the introduction of NFV and modern cloud-native applications, you can no longer operate those with the increased complexity. You cannot use static rule-based analytics and human observation anymore. You need something intelligent, and that's why operators are going to implement horizontal implementations of OSS and BSS systems to pave the way towards much higher automation. Many of our customers have already created data lakes, and to cope with the massive amounts of data, but now are looking into how to make use of that data and develop AI models for various analytic use cases. In the box here above, you see some of the most important use cases that we see. This is all about KPI, network KPI predictions, anomaly detections, correlating faults, and another very, very big domain is the whole area of capacity planning, right sizing the network. So to build such a horizontal OSS BSS system with integrated AI ML analytics, you need to build a strong data analytics platform that copes with the massive amount of data you ingest, and you need to pre-process, store in various forms and databases to be able to create models that predict and detect all these different use cases from the data. So we'll take a closer look at such a typical telco AI pipeline, which typically gets data from all across the network domains, many different attributes, metrics, counters, but even logs and traces from servers, from applications, from the network components themselves, and also augmenting that with metadata, geolocation, topology, etc. And typically, and that's basically true for most of the time series metric analytics pipelines, you would feed that into a machine learning model where there is dominant frameworks out there that are typically being used, such as XGBoost, TensorFlow, PyTorch, really depending on the outcome of the model. I've only named a few here. The most important or the most relevant ones that we see today. But they all follow basically this very same principle. And depending on the outcome, you may implement many of those pipelines for the different purposes. Taking a deeper look into that is that you typically receive data from various different components in various different formats. Traditionally, telcos have worked, or the elements have worked with lower granularity data, such as 5 or 15 minutes data, which is still suitable to train some of those models. But more recently, we see modern cloud-native applications streaming data, typically on message buses in a JSON format or other, that you need to ingest with much higher I/O requirements than you would do in a batch processing. So the ingestion phase is an important step to collect all the data, possibly do some conversion and compression before you feed it into the pre-processing stage. The pre-processing then will do many things. It needs to parse the data. It needs to normalize data. As I said, most of the data will be time series, but you might have other unstructured data that you need to transform. All that is being done in the pre-processing part with many different arithmetic functions that you find in typical frameworks. And finally, you'll merge it, flatten the dimensions and the features so that you get a real dense training set of data for your machine learning portion. Like I said, many of those problems can be solved with ML, classic ML, such as XGBoost libraries. And from a recent project we've done with a customer, we have implemented and analyzed this pipeline with real-time data, with large data sets to characterize the different stages and their various compute and memory I/O requirements. And we actually found that the pre-processing part, the blue box in the middle, took most of the compute time compared to the training part, which was only 30% and the ingestion 10%. And that was just before we actually started to optimize the pipeline using specific acceleration features of CPUs and the libraries that enable them to actually free up 57% of the compute by reducing the pre-processing part by 4x. So that's a significant acceleration that we can achieve in this pre-processing stage. And then also, of course, we can optimize machine learning and deep learning algorithms to run optimized on specific instruction sets and accelerators. So just to give you an idea on typical operations use case, working with time series data, mostly structured data, your compute requirements will heavily be driven by the pre-processing stage, but all of that can nicely run on classical CPU architectures. With that, I'll hand over to my colleague Kevin, who will talk about similar implementations, but in the radio access network. Kevin, over to you.
Thank you, Michael. Hello, this is Kevin from Intel. I'm going to introduce the RAN AI use case. Again, this is a high-level use case level introduction, so I will not go too much deeper dive, but if you have detailed question, we can have a Q&A or offline follow-up. So as you see here, telecom industry, definitely driving the power of AI to realize the RAN benefits. And then, your network getting complex, many services and different quality and SLA requirement. And then that's where advanced machine learning, deep learning, and now it's moving to Gen AI as well, because operator has the massive amount of the data coming out from the RAN, also coming out from the platform, because they are bringing the RAN as a cloud native environment as well. And then they give us a few use cases, such as improve the network performance, like the cell performance or users channel quality. And then another use case is the energy saving, either cell on and off, and even into the BBU level. And then the other use case example, the ensure the service qualities. And then it could be the other one is the predictive maintenance, to reduce the network downtime. And today I'm gonna introduce the only 3 use cases that Intel deliver at the MWC 2024. So let me show one by one. Thank you, Michael. And this one is the first use case is the power saving. And energy saving is, we sense that it's very high priority use case among, I would say, the most operators, right? And this energy saving is specifically for the CPU level power saving. And by the way, this is a screenshot of the live demo. If you look at the bottom right-hand side, there is a YouTube link that we posted, so you can watch the live demo video there. But if I explain some of the use case, what it looks like, this is based on AI-based CPU frequency scaling, meaning you can increase the CPU frequency goes up, you can decrease CPU frequency goes down, dedicate for the virtual DU. So AI model trained based on the RAN and platform specific data to find out the best CPU frequency, meaning in a way to maximize power saving, but make sure there is no RAN performance drop. So if you look at the top right-hand side corner, you can see CPU frequency, go up and down, changing dynamically. So basically, AI model look at the traffic volume. So you can imagine easily, like if input traffic volumes goes up, CPU frequency is supposed to goes up, and the vice versa. But depends on situation, even traffic volumes goes down. If RAN specific parameter, such as here is a force row, the phi delay is a virtual DU processing delay, goes up, then CPU frequency is supposed to goes up because there are little traffic volume, but your latency is very, very important metric. So you should, in that case, increase the CPU frequency. So this is very AI model fine-tuned for the RAN, especially the virtual DU specific use case. And then we run this AI model at the non-real-time rig. But definitely this AI model can lens on the near rig. It can run everywhere AI. It depends on your control loop. And at this demo, we control the CPU frequency every 1 second. So if you look at the right-hand side, it shows the kind of percentage of the power saving compared to the you fix the CPU frequency, which is the most default configuration. So for this, we work with the operator who share the live data set, 24-hour data, high traffic profile, low traffic profile, and then compare what the power saving percentage looks like. So this is the first demo. And second demo is the user level beam management. This is also very, very important use case for operator in terms of improving user channel quality. And in this demo, if you look at the left-hand side, you can see the 5 users. Actually, it's also a video, but the 5 users around the base station, the yellow color base station, some of them in the cell center, some of them in the cell edge. And we simulated these 5 users' trajectory based on the operator specific environment and cell environment. And then we captured the user's throughput as a aggregated throughput, and then user's delay, when they moving from cell center to cell edge. And what AI doing here is AI captured UE position information and channel quality information and decide a target beam for the UE specific, meaning some of the beam features like the horizontal, vertical angle, and TX power, and number of layers per users to maximize the defined function of reward, which is the throughput and latency. So we train this model, and then we test this five user trajectory. So right-hand side, if you see the green color is showing the some of the RAN metric based on AI, versus yellow color is based on our operators operator partners' existing baseline. So this is a snapshot, a combined of certain users are cell centers, but you can see some of other users moving to the cell edge, right? And then you can see the AI based beamforming, beam management shows much higher throughput. In this case, 115 megabps of the five users aggregated throughput. And then delay point of view is like 3x difference, right? Compared to non-AI base. So I just want to highlight this is a operator specific problem statement, and we somehow we observed that this is we tested this a FDD base where beamforming based on the PMI codebook. So this is one of the examples of the AI applied to the user level beam management. And the last one is a network slice radio resource management. And this is all about the slice radio resource allocation, which is actually PRB resource allocation. So we wanted enabling, which is called the soft slicing, meaning allocating radio resource in a real time in a dynamic way. So for this demo, we run the 2 slices, and one is the primary and prioritized slice, and you can see this screen as a cloud gaming is part of the primary and prioritized slice, where especially delay latency is pretty strict, versus the other slice is just for the regular traffic download. And we make network congestion environment. And then how AI allocate the PRB resource in a way to meet this priority slice KPI, for example, like the bandwidth and latency. And in this case, our operator partner gave us kind of cloud gaming latency as supposed to be always less than 5 milliseconds. And we run AI on Neartric to allocate slice level quota every 1 second. But also we run AI model sit together with the DU, virtual DU, to control UE level allocation. So you can imagine even in the same slice, different UE may have different position, different channel quality, right? Then your RB allocation is supposed to be different, meaning, in the poor channel quality users, they should get more PRB. So it's not something simply uniform the slice level quota, but it's in addition to the slice level quota, we also enable the user level RB allocation at the TTI level. So, right-hand side, you can see the most of the latency, is like 3.6 millisec versus the left-hand side. You can see the latency is 139. It's a violate. We compare this a manual-based PRB allocation, which is a triggered based on the application-specific metric monitoring. If you violate application KPI, you manually allocate the PRB. But it's difficult, right? So it will end up like reserve PRB for the prioritized slice, but it will end up like waste of your resource. It's not dynamic, it's not real time. So that's how I give a dynamic and real time level of the quota allocation for this use case. Okay, let's move on to the next agenda.
Yeah, my piece here is all about another of the 4 pillars of use case. So customer experience. We know it's very central for the telcos, and think of it this way, right? All of the subscribers, certainly all of the customers, they definitely want more seamless interactions, but definitely more communication. It's all about customer loyalty. We know that the more we can interact with the customers, the more customer loyalty we get. And in that context, large language model or ML model, DL model can really help us and give us some features to improve that communication speeds. But because it's AI and ML and using all the data that sits inside the organization, the telco organization, we can also look at how we can optimize the interaction with the customers and the subscribers, making sure that they have a very efficient process and very efficient experience in terms of the engagement, pulling a lot of the information that sits inside the firewall of the organization, including contracts and pricings and portal information and services kind of information, and bringing that all together in front of the customer in a seamless fashion. And ever since the 21st century, it's all about personalization. Everybody wants a very individual experience. Everybody wants to be treated as an individual in terms of the services they receive and the services they pay for. And LLM can really help us build that hyper-personalization interaction with the subscriber and with the customer. So all of that combined really makes the customer experience probably one of the most central piece of the pillar. Obviously, network operations, obviously business improvement inside and new revenue streams as the 4 pillars, but customer interaction is probably also very critical. This is what I call also the progression of C. Historically, obviously, we used to rely on contact centers, and contact centers morphed into chatbots. The chatbots themselves were really very limited because they were text-to-text type of engine or type of tool, responding to keywords and responding to keywords by leveraging pre-prepared text and pre-prepared answer. And that seems like very robotic type of environment. So the chatbots evolve into more concierge type of interfaces. And that's where NLP, language programming, really helped getting that more natural conversational type of environment. And then those concierge, as you will see, in fact, have evolved into a more coach. And so here we have an example of a concierge or an avatar or a digital agent, depending on how you want to call it, and showing also that AI and large language model in particular allows really that interactions to be really much more personal and much more effective. On the left-hand side, we talk about really realistic faces. So the tools allow today to really have all the muscles working in a correct fashion, but also the color of the skin, the tone, the contrast, the layers, make it for a really, realistic headshot interface. Obviously, mankind had 4 billion years of evolution to train their eyes, but we're getting very close to that human interface and human, face-to-face interaction. But because we are social animals, it's all about also body and gesture. And so not only we need to have a realistic face, but also a realistic movement. And that movement is also linked to the whole body. So the gestures needs to be coordinated. It's not really much robotic or even not disconnected to the language and the speech that comes out of the avatar. And of course, something very dear to the telcos, no lag, no latency, something really real time. So the experience of the subscriber, of the customer using those kind of tools needs to make it a really as realistic in terms of interaction and real time and response time to the request. And so not only we have this progression of C from the contact center chatbot to concierge to coach, but we also have here from realistic facing, realistic body interactions, but then also realistic, speech and personal interactions in real time. So next up, we need to look also at the type of architecture that sits behind. Obviously, the user doesn't see that, or the subscriber or the customer doesn't see that. So that black box obviously has evolved, as I said, from the contact centers of the past to those very robotic chatbots to tools today that really mix up speech and text together. And so allowing for that combination of text recognition and response being made by speech all of the building blocks that we have here need also to be working in clear conjunction. So having those bots or those concierge or digital agents now being able to interface and react to speech, translate that into text and respond back into speech. So we're now not only going from a text to text, but we're now talking on speech to speech. And this example here, we've been working with a company called DeepBrain, and DeepBrain allow us to do that video generation, which allows them to go real texts and speech and really have response being generated by video. And you could see here in the two use cases being done by one of the telcos. On the left-hand side, this is an application really targeting more of the retail. So it's a kiosk avatar or kiosk type of digital agent that interacts with the customer in a personalized fashion and responds obviously to speech by direct video, and the video is being generated by the language and the NLP engine sitting behind. On the right-hand side, you see here the next generation, which is really then the coach level, where in fact the coach or the engine here responds not only to speech, but also to specific data being collected by sensors. And those sensors also then are being used to generate an input based on video. And so not only we do data to video output, now we can do video to video input and to video output. So you could see that the progression of C means that we had chat box essentially text to text, and then moving to speech, and here with the LLM technology that's available, we can do really video and other data to a video output. Now, I need to say this is also a good moment for me to say that, with all of AI and ML being deployed and all the potential use case and application that's in application development area that's available out there, our role certainly between Lenovo and Intel also needs to evolve. And so the way we approach this is also by providing all of these use cases, and as you see some of them today, but also some specific ISVs or specific partners, and bringing a whole ecosystem that really leverage very specific applications in very specific vertical industries. So our role is evolving us just as much as in fact the application development is evolving. And so yes, just before I pass on to Kevin, I don't want to leave you with the fact that it's all about Gen AI and ChatGPT. ChatGPT is a really large model. There's on the version 3.5 and on V4, we're talking 1 trillion parameter, something like 32,000 token, if not more. But what we're also looking inside the organization and with our friends from Intel is how can we bring the power of LLM in an enterprise fashion, in pre-trained model, but also in things that are as small as possible in terms of compute. So the inference model and the inference layer where we deploy the application is very critical. So how do we bring those AI use case also on handsets like we do with Motorola smartphone handsets here? So Kevin, why don't you talk about the foundation model range that's available right now?
Yeah, sure, of course. So this is a traditional journey of your Gen AI development. You start from left-hand side, a large foundational model, GPT-3, GPT-4, it built a large amount of the parameters from more than 100 billion to trillion. And it's broader use case purpose and definitely supporting multi-model. And there are other open source version of GPT you may already familiar, like Llama, Falcon. They are pre-trained model, but a little bit more task specific. So it's not like super versatile, but it is very well pre-trained, and it support the multiple tasks like the Q&A, summarization, code generation. And it's a less size of model compared to the foundational model. And then enterprise, telco as also enterprise, either finance, manufacturing, starting to build GPT enterprise, meaning you have your own domain data set, and then you start the fine tuning of your to build your own model based on this open source model, right? And then it doesn't require a huge amount of data. It's supposed to be small amount of data. And finally, when you go to deploy this model, you need taking some quantization and compression technology, because when you deploy this large language model, you need to understand where the inference happen. It could be data center with the Xeon, data center with the server processor, or it could be your PC, and then it could be your smartphone. And the AI target latency, like the token generation, is critical factor. So you should consider where your deployment happen, right? This is shows some journey of this LLM. And Michael, let's go to the next. Yeah. So I will not walk through all the simple detail, all the detail, but this will show the development life cycle and what you should consider, like starting from use case selection again, and you pick up the pre-trained model, Llama, GPT, J, Falcon, and then you need to build your own data set. You need to build your own instruction data set based on your target task, right? And then you start fine tuning, and fine tuning also require a lot of compute resources. It's very, very expensive. So whenever you do the fine tuning, you need to think about the compute efficient technology such as the FEFT or LoRa, which is the parameter efficient fine tuning, or LoRa as one of the must enable technology for your fine tuning. And even when you go to the inference, not only just simple quantization, there are a bunch of technologies coming up to improve the inference performance, like the even VLLM or the dynamic batching, and even LoRa is used for the inference. And the last one, before you serving the model, the retrieval augmentation, which is called RAG, is really, really critical for enterprise AI, because you should not rely on 100% on your pre-trained model, fine-tuned model. You should have the knowledge base and combine the knowledge with your model to generate the right answer, to avoid any hallucination or generating wrong answer. So this journey shows required a lot of effort, and you see the bottom side, what are the industry choice of the library, repository, and even Intel optimization for those building block. And I just want to share one thing. 2 weeks ago, Intel announced a open platform for the enterprise AI on the Linux Foundation. We want to make enterprise AI easy for the customer, enterprise customer, to build a end-to-end LLM pipeline. Like putting together is going to be complex task for you. So Intel announced open source initiative to put together entire pipeline and end-to-end flow. So you can reach out to us. I'll share the link through the chat, but I just want to highlight that as well. So summary, Michael. Yeah. So what we covered is we covered the key driver of the telecom AI implementation, and we covered different AI technology. Sorry, it's just 1 hour webinar, from the machine learning to the deep learning and the Gen AI. It has different target performance requirement, and then it lands on the networking side, the core and edge and B2B and B2C use cases. So you need to design a balanced infrastructure to maximize your ROI, instead of you just putting together all the training infrastructure and then ends up like, you don't maximize your return on your investment. And like Lenovo Intel deliver webinar today, we have a great partner and ecosystem and hardware and software and tools and libraries and optimization. So we'd like to partner with you for the further opportunity and then further innovative use case. Then our next step is we have a deeper dive session based on your important use case and topic, and at the next face-to-face meeting. With that, I think we have 9 minutes left, right? So
yeah, perhaps I can introduce the Q&A session, and in parallel, we will post in the chat channel also a link to a small survey. I do realize that some people may start leaving as we approach the end of the foreseen time, but we really would like you to fill out this survey. So before leaving, can already start to have a look at it now. It only takes 2 minutes to fill out, but it would be very good to get your input to continue our discussion also in Prague. So first of all, a big thanks to Lenovo and Intel for all the use cases and the strategic view they have on the topic. We do realize that this is only a teaser or even a glimpse in some cases, but as said, we want to go in depth in Prague in the discussions in all these use cases. But so we already have some questions, I think, in the Q&A channel. And I think there was a first question already coming in, probably after the remark I made on the Mobile World Congress, that everybody is into AI, and we all know the Gartner cycle with the high expectations in the beginning, and then the period of disillusions before then really entering the era where the technology is used to the max. So it would be good also to see whether you agree or to have your view where we are in the hype cycle. It's fair to say also with other discussions we had with the operators, I think there are people who are a big believer already. There are other ones who are more reluctant still on the opportunities. So how would you prescribe your view on the position in the hype cycle of Gartner?
I'll give it a shot, Wim. Having been in this industry for a while, I think a long time, and in the AI industry for also a long time, I think the hype is really on ChatGPT, because I think that's where a lot of kind of attention has been focused. If anything, in the telco industry, telcos have been using analytics, big data, machine learning, deep learning, and to some extent LLM already, and have not waited for ChatGPT to break into the consumer space, if you want. Yes, it will change the way people are developing applications. People are looking at process. People are certainly looking at, hey, can I do this better and in a more automated way than before, and using all of that. But it's not there's maybe a hype cycle on ChatGPT in particular, or ChatGPT-like type of super large model. But there is an undercurrent for me of a very interesting small language model, like Kevin was showing, a pre-trained model that are really optimized for very specific tasks or specific, industry. So we know that there are a lot of models out there being trained right now on telco specific data and using that as a tool. So it's like a toolbox. Which tool do you pick from your toolbox to do what? You don't take a hammer to put a screw into a piece of wood, but you have different things, and you don't want to put a big hammer like ChatGPT to maybe solve a very specific application, a very specific customer problem. So hype cycle, yes, certainly linked to ChatGPT and their equivalent, but there is a very strong undercurrent that's changing, I think, in this industry, which is all about, can I use ML in a different fashion? The deep brain example that we showed here is just a way to show that we've moved from text to text to speech to speech, and in fact we can generate video automatically with a pre-trained model. So it doesn't require a huge data center with several weeks and months of training, and then maybe a very specific series of racks to do the inference. We can really be effective in the way we deploy these kind of applications.
Okay, thank you, Dominic. Perhaps Before moving to the next question, please don't forget to go to the chat channel and fill out the survey by clicking on the link which is posted there before leaving the Teams webinar. I think there is a question also related to the usage of AI in security operations. I think it was not really addressed as a use case in this webinar. But does Lenovo or Intel also have use cases related to security operations? And
if
also,
I may give it a
whether
shot,
these are new.
Yeah, and I'll let Kevin or Mike pick it up. But we have a use case like that. Obviously, fraud detection, traffic monitoring, all sorts of security linked to the network, all things linked to enterprise security are also quite interesting. This is, if I take just network security and fraud detection or wiretapping detection, these are techniques that are really data-driven today, where telcos, and we have a couple of cases where are using analytics and big data right now and are applying now model based on machine learning to go into that path. Again, it's a continuum. It's like a progression in C. It's a progression of evolution. So the data is there. We can really handle it in a big way, and now we can be smarter by using ML. So yes, it is. It's typically fraud detection and network security.
If I quickly add on, yes, it's more than what Dominic mentioned. So you can imagine malware detection, malicious URL, DLP, everything was based on the rule base. And then what AI giving is a capability of detecting new attack, every new attack generated. So that's where machine learning showed the benefit, especially for detecting unknown. And your question is looking for, is there any new use case coming, right? That's very good question. It is for now improving existing use case, but I would say security operation is one of the use case leveraging AI, especially Gen AI and LLM, because there are too many incidents happen, and then they figure out where this security attack coming, right? So they need to look at a lot of different data. So those security operation could be a new use case leveraging AI. But most of the use case is to improve the existing use case based on the AI. Yeah.
The really new ones is for me linked to incident response. So when you have a break of some sort, could be a failure, could be an attack. But let's say when you have a break in the network, the incident response driven by ML and large model can be really now accelerated and go into a much faster fashion. Don't forget that one of the benefits of deploying AI is going from really reactive type of mode to something which is really predictive. And so injecting some prediction technologies and prediction monitoring, you can really then improve your incident response time. And that's, I think, the next kind of step that we will be seeing.
Okay, thank you, Dominic and Kevin. I think we're reaching the end of the webinar. It's 11 sharp Central European time. So I want to thank again the speakers of Lenovo and Intel, also the team for organizing this webinar, and of course all the people participating in the webinar. We'll send the slides out today together with the link to the recording. We'll also add the survey again, but if you can, please fill it out still before leaving the call. And I want to conclude with a warm invitation to join us at this gathering in Prague in more or less 6 weeks from now. We will have plenty of time, 2 days, in fact, to go a lot deeper into all the topics we already addressed today. So have a great day, all of you, and thanks again for participating, and see you soon. and hopefully in Prague. Take care.
Thank you all.
Thank you.
Thank you. Bye.
See you.
all.